I have some calcium metal in water. You can see that the calcium metal is bubbling. I'm going to add some more calcium metal to the water, and you can see that the calcium metal is fizzing like Alka-Seltzer. The bubbles you are seeing is actually hydrogen gas being given off. The calcium metal is reacting with the water to form calcium hydroxide and hydrogen gas. Now I'm going to take another beaker, turn it around so that the label is on the back side, and fill it with some deionized water. Now I'm going to add some magnesium metal to the water. What we observe is that the magnesium metal is not reacting in the water, period. The magnesium metal is in group 2A of the periodic table and should react the same as the calcium. In a moment, we will take a look and see why we do not see any bubbling with the magnesium metal, period. It has to do with the location of the magnesium on the periodic table. So we will let this reaction continue with the calcium, and you should be able to see it is bubbling very, very rapidly. Look closely at the magnesium, and nothing appears to happen. Now let us examine the chemical reaction that we observed. The solid calcium metal reacts with liquid water to form calcium hydroxide and hydrogen gas. Because the calcium ion has a positive 2 charge, it requires 2 hydroxide anions, which are negatively charged. Therefore, 2 water molecules must react with each calcium atom. This reaction is extremely exothermic. Therefore, we can add an energy term to the products side of the reaction. As you will see, I did not put a state for the calcium hydroxide. You will learn later that calcium hydroxide is only somewhat soluble in water. Therefore, the initial calcium hydroxide that forms will be aqueous and soluble in water. As more and more calcium hydroxide forms, it will precipitate out of solution as a white solid. Hence, as we let the reaction continue, the solution in the beaker becomes cloudy due to all of the calcium hydroxide that is precipitating out of solution. Let us examine the similar reaction for the magnesium metal. We will discuss in a moment why we did not see much of a reaction with the magnesium metal. Magnesium metal should react in the same way as the calcium. That is, one magnesium atom should react with two water molecules to form one magnesium hydroxide and hydrogen gas. The problem with this reaction is that the magnesium hydroxide has almost zero solubility in water. Therefore, the reaction will proceed only slightly before it stops. However, magnesium metal can react readily with gaseous water in the form of steam to form magnesium oxide and hydrogen gas, according to the equation shown. One magnesium atom reacts with one water molecule in the form of steam to form one magnesium oxide molecule and hydrogen gas. Because the magnesium cation is positively charged and has a charge of 2+, only one magnesium metal atom is required to react with the water. The oxygen in magnesium oxide has a charge, of -2, and therefore there is a 1-to-1 ratio. Okay, let us look at the periodic table for a moment. The reactivity of the alkaline earth metals increases going down the periodic table. Therefore, if magnesium metal readily reacted with liquid water, the reaction would be a lot slower and less vigorous than the calcium metal. Magnesium is in the third period of the periodic table, and calcium metal is in the fourth period of the table. So as a recap, calcium metal is much more reactive than magnesium metal in water. While the position on the periodic table dictates that the calcium should be more reactive, the reason why we did not see much of a reaction with the magnesium metal is due to its extremely low, almost zero, solubility in water. That is, the magnesium hydroxide has almost no solubility in water.